All right, good afternoon or good morning to everybody on the West Coast. Welcome to day 2 of AABC's virtual annual meeting webinar series. Again, I'm Ray Burt, Executive Director of AABC. We're very pleased all of you could join us today. We're going to take just a brief moment for a message from AABC member and sponsor of today's webinar, Engineered Air Balance. We'll be back in just a minute and kick off the first technical session.
At Engineered Air Balance, you can feel the difference. We are a leading authority in total system balancing and building commissioning at the forefront of industry standards and training. The difference is our comprehensive approach to total system balancing, which continues to advance the industry's benchmark. The difference is our expertise in building commissioning, which encompasses HVAC, electrical, plumbing, and life safety. The difference is our state-of-the-art training center located in Houston, Texas, where we are uniquely equipped to train the next generation of technicians. And finally, the difference is our team, whose technical knowledge, unmatched thoroughness, and continuous reliability sets us apart, allowing us to deliver an optimum operating facility. To learn more about how we can make a difference for you, go to eabcoinc.com.
All right. Thank you very much to Engineered Air Balance for their support of today's webinar. I'm going to give you a few quick Zoom notes. If you have questions for our speakers, our panelists today, please use the Q&A function at the bottom of your Zoom webinar window. And again, you do not have to wait until the end of the webinar. If questions occur to you along the way, go ahead and put those in. We'll queue those up for when they take questions at the end. If you have any technical issues, we hope not, but if you do, please use the chat box for that. Our technical specialists will assist you as best they can with that. For our presentation today, we've got an hour and a half on field analysis of HVAC systems' ability to mitigate COVID-19 transmission, about as topical as you can get right now. And we have our all-star panel, I'll say, for this presentation. Justin Garner with Engineered Air Balance in Houston, Troy Byers with Palmetto Air and Water Balance in South Carolina, and Wade Conlan, Hanson Professional Services in Florida. So with that, I will hand it over to them. Take it away, guys.
Thanks, Ray. Appreciate the introduction. And this is, you get credits as Ray noted. Not going to dwell on that. Just want to once again thank EAB for sponsoring and the other, and Hanson, and commission, for allowing us to be part of this presentation. This is the course description and the learning objectives that we sent out initially, right? So we're going to talk about how to evaluate your HVAC systems, understand a little bit about the transmission and transmission paths, and really dig more into the mitigation strategies, and talk briefly about a building readiness plan. So between the three of us, we're going to touch on the ASHRAE Epidemic Task Force and its transmission and building readiness. And then, like I said, the meat of it is the ventilation and filtration. And then the question and answer. And then we have allowed for quite a bit of Q&A. So please do ask questions. Make sure all the tough ones are for Justin. At the end of the day, we really do want questions and answers. We want this to be as interactive as possible. So please go ahead and start doing the Q&A. So the ASHRAE Epidemic Task Force was formed in late March, early April. The ASHRAE XCOM reached out to a few of the standing committees. I happened to be chair of Environmental Health Committee, and in discussion between the different committees and the ASHRAE board XCOM, we were asked to create the task force. And so fortunately, Bill Bonfleth agreed to lead the task force. As a past society president, it really helped in his background in IAQ. And so when the task force was formed, we really talked about, okay, what are our needs? What do we really need to address? How can we help? And we looked at it in three different modes, right? Mode one was the immediate. That was the COVID-19. Mode two was the near term, which we talked about, which was the second wave, which is kind of where we're sitting today, getting into. And then the third was the long term, is And that's the reason it's called the Epidemic Task Force, not COVID-19 or not pandemic, is the intent is we're coming up with a lot of good guidance for how to deal with infectious diseases, specifically in this case right now, it's the SARS-CoV-2, but we didn't want to lose that information. We want to make sure that that got into the other guides, the ASHRAE handbooks and all those kind of things. And so at the beginning of this, the teams were formed. The biggest area was, okay, which buildings did we really need to deal with? Which buildings should we address, right? And so residential, commercial, schools and universities were what I would say were the second grouping, because the healthcare was already off and running. Obviously, they're the first line and they were being hit. And so their guidance was already being established between ASHRAE, ASHE, and a lot of other individuals there. So we said, okay, let's start creating these building guides that'll provide guidance and information and recommendations. We also said, okay, well, we know filtration and disinfection is going to be a huge piece of this. So there's a team here led by Dr. Steve Martin and Kathleen Owen. And this really gets into, and what they've created really gets into talking about filters, the MERV ratings, all the information, and all the different disinfection technologies. So, and there was another group that was called commissioning, and that's the group that I was tagged to lead. And as we were building some of this other guidance and going along, we kept saying, okay, well, how is it really commissioning? And as we started thinking about it, okay, people saying, hey, how can you help us get our building ready to shut down, right? And remember, this was April, May, or to be unoccupied for quite some time. And then we said, okay, well, we're going to have to get people to be able to reopen and then also evaluate their buildings before they reoccupy. And so that's where building readiness was born. Now, it's in the middle and it's the largest, and probably because it was individuals on the building readiness team that helped create this. And so, but in essence, we broke it down by epidemic conditions in place and post-epidemic conditions in place, which really is, here's where we currently are, and we really want to get to this location here. So this infographic, everything actually, if you go to the website, everything here has a live link. It has, the different available resources, and then where you can ask questions specifically to the task force, which they've answered over 900. So a lot of guidance has been created and updated. Just a little, where is it headed? There's currently a labs team. There is a assemblies of faith team, a retail team, and industrial team that are working on guidance coming out. And then there is one other that I wanted to talk about, which is this literature and scientific review. This actually links out to a Google sheet that actually has all the different articles. At one point, it felt like there was like 1,000 new articles a week coming out. And so they were trying to review those and analyze those and provide a synopsis for how it impacted the HVAC system, right? With that, so this building readiness team, like I said, I lead it. Justin and Troy are part of it. And so this building readiness team includes, commissioning providers, designers, individuals from the test and balance world, controls world, owners as well. And so it really is a nice collection of individuals that you'll see that are a part of this. So, the task force, like I said, it's epidemic and trying to look towards standards and guides, et cetera. So there's now also a research team that is trying to find the gaps of where some information needs to be to further prove different ideas or comparisons between two different strategies, right? Justin is going to be presenting on ventilation, and Troy is going to be talking about filtration. And so which do you do? And so that scientific application team is really, they're trying to figure out, okay, what's the biggest bang, better approach for you or your building or your client. So that's the task force. So let's get into transmission. And when I talk about transmission, and this is one of those slides that I really love. I love the image of it. We've all seen, the SARS-CoV-2 image here. And when you look at it, this is actually a blow up of this little gray dot over here. The virus itself is 0.06 to 0.14 micron, and you can see the different particles as you come across. Now PM 2.5 and PM 10, those are used kind of to evaluate the quality of your outdoor air, and so they're shown here for that. But what's interesting is the reason it stops at PM 10 is that is the smallest particle that you can see with your naked eye, right? So you can see in comparison how, if this is, when you're driving and you turn the corner and the sunlight just hits it just right and you see those dust particles in the inside of your car and you're like, what is that from? That's PM 10 size, right? So you can just see in how much smaller it is. We do know a good bit about the virus, but now, if it's going to be transmitted, you have to do indoor air quality control, right? This quote came from Bjorn Olsen. He said it to, or I believe he said it to Bill Bonfleth, and there's a lot more context to it than other than buildings are people for not for saving energy. I mean, the intent is to build buildings to be as energy efficient as possible, but in reality, they're there to protect people. And so that's one of those things. As we move into this IAQ control, there's a lot of buildings out there that were built for comfort, if you will, and that we're now trying to operate more in a safe mode, like more of a hospital laboratory. And so there's a different shift in the priorities of those buildings. But when you get into IAQ control, you need to understand the different transmission modes that are available, right? Airborne, this was obviously a hot topic, very debated over a long time. People are now fully on board with it being airborne. And then the other ones that HVAC impacts is this fomite, or the intermediate surface. And this is one of those where it hits the surface and then it gets re-entrained into the air. It's actually the task force, they are actually sharing some different information on issues with some animal facilities where different viruses, they were from one animal getting passed to another because it was getting entrained. So for HVAC, we're going to mainly focus here on the airborne. And so if you're going to do IAQ control, where does that fall in line? This image is from NIOSH, and it really talks about the different levels, right? And the intent is elimination, getting rid of it. I'm going to call it having a vaccine for the strain that's out now, would fall under elimination, and we hope we get there soon. For HVAC, we fall under the engineering controls, and that's what we're going to focus on. The administrative controls, that gets into how many people are in your building, what flow you're going to have, what kind of occupancy you're going to do, what activities you're going to allow in your building, those sort of things. And the bottom one here is PPE, and that's masks. And masks are extremely important. So this is the standard hierarchy of controls. But like I said, we're focused in on this HVAC, but these impact what we'll call the bioburden that the HVAC system would have to overcome. And they all need to be followed, right? And so to some people, this PPE is even bigger. And I've actually seen diagrams where this triangle is flipped upside down and the rest of it stacks on top of it. So, but everything has to be worked together, but we're going to focus in on the HVAC, or the engineering controls for this. So the task force came out in early April, made a couple statements. The first of which was based on different science at the time, different research, the Hugo Lee study on the Guangzhou restaurant, which is pretty infamous. So ASHRAE came out and made a statement that transmission was sufficiently likely to be airborne, and therefore your HVAC system played a part in this, right? The other one, and at the time, if you think about it, Europe and others were hit before us in February, March timeframe, where it's a bit more moderate. And so organizations over in Europe said, if your system recirculates, shut it off. And what ASHRAE said is, hold on a second, let's think about that. There could be other thermal stress to people. Unfortunately, when you think across the country in the middle of the summer, unfortunately you see a heat wave and you hear of individuals dying because they had no air conditioning, or in the summertime and the wintertime when they don't have heat, or the heat got turned off and people passing away. And so there's other impact of thermal stress to people. And so what ASHRAE came out and said is, in general, don't disable your HVAC systems to reduce the transmission, right? Now, this Guangzhou restaurant, this image here, it really does paint a picture of what we're really going to be getting into. These are ductless mini splits. There was one person over here that was asymptomatic. This unit, just kept recirculating the air in this bucket. The people that are red are the ones that became infected. So even in this zone, you can see other people were still yellow, so not infected. And you can see as you go through the rest of the restaurant, because this system just kept pushing across itself. It had no ventilation and extremely poor filtration. And so at that point, you can look and say, yes, the HVAC system played a part in this. Now, okay, that's in the space and that's a mini split. So what about a larger unit, Wade? Does that really impact? And so this was a study done by the University of Oregon and the Institutes of Health. This identification of SARS-CoV-2 RNA That is the actual title of the academic paper or the research paper. So they had an air handling unit where they took in an actual building where they were taking measurements in the L, M, and R at right before the pre-filters, right before the final filters, and they had dampers on the downstream of the MERV 15 final filters, and they took readings here. In these boxes, you can see the number of readings and the percent positive, and then you can see that downstream of the MERV 15 filter bank, they actually had positive readings for the RNA of the virus, right, of SARS-CoV-2. At the time, they weren't set up to check the virality of the viability of the virus, and that's currently, I believe, what they're doing now, trying to figure out how to take, like I said, it's an operating building, is they're figuring out different ways where they could take live air samples or samples of the airstream without disrupting and shutting things down. Troy's going to be talking to you about filtration, and that MERV 15, there's some theories behind it. So what was different about this study is up to this point, a lot of the studies that you had seen were dealing with the space because they were dealing with sick individuals and how is the cleaning and are we getting it back to sanitized? Is it in the airstream? Are the workers safe or not safe? And so they focused on the room as a box, right? Well, what this did is it said, okay, and even in those, they would look at the return grills or the supply registers or diffusers, and they would take measurements on those and they would find samples of the virus, but they never went beyond. And that's what this study did, is actually went into the ductwork, went into the air handling unit, and really is great because it really shows that, yes, there is virus within the HVAC system, not just in the space. So transmission is airborne. We do need to look at our HVAC systems. And so now you need to evaluate, is my building ready to have people in it or to bring people back in? And so the building readiness guide was this part was created, and it really gets into how to operate your building and really practical guidance, right? So if the commercial guide says, hey, increase your MERV filtration to X amount, this talks about what is that impact. If increase your ventilation, and it talks about how much can your coil handle and other strategies, and as well as how to evaluate that. And that's stuff that Justin and Troy are going to get into. But you have to look at epidemic conditions in place and think about your occupancy. When am I going to be at pre-pandemic or epidemic, or am I going to be at reduced capacity? Like my office building right now, we're at 50% max. That a lot of buildings were temporarily unoccupied. So how are you going to reopen those? And then this prior to occupancy, there's actually, and I need to update that, there's kind of a prior to occupancy up here because people are occupying during the epidemic. And then once you're done, some different considerations. And so your building readiness plan needs to think about all these different things in addition to the non-HVAC strategies, right? Mask and people direction and one-way stairs and all those kind of things. And so your building readiness plan needs to incorporate this. And that building readiness plan is going to be phased as you go through, as you increase, right? We're, like I said, my office is at 50% occupancy. If we go to 75 or 100, we need to look at, okay, is that going to change anything that we're doing with the HVAC and or with people? This is a team game. This is not not a one individual comes in and saves the day. Very typical within our industry, right? It is always a team game to get a building built, to get retro commissioning done, to get test and balance completed. All of it is always people working together, and this is no different. I list a lot of different individuals here. I list commissioning provider first, not only because that's what my focus is, but more so because I think they're extremely suited for this role, right? The normal day-to-day for a commissioning provider is to look at how buildings are supposed to operate or are currently operating, and how can we make them more efficient or optimize them to be better, whether that's for energy, safety, maintenance reasons, etc. And so from that standpoint, this is just another thing to evaluate that building. Look at my building, how is it operating? Now I'm also going to consider some of these different mitigation strategies. Test and balance. A lot of people, one of the things that ASHRAE says is maintain code minimum ventilation. We've all been in different buildings where the dampers aren't opening, the dampers aren't working, airflow measuring stations are out of calibration. And so that and I'm going to say, competent and the professional and the trained test and balance specialist or technician is critical to be able to see how those things are they actually performing that way. As well as everyone else. The bottom two here that are listed, owners, facility staff, and building operations. I always list them separately with this, and the reason is the facility staff is that HVAC technician that actually runs the building and actually deals with the system or the BAS, or they're the ones that have been putting the band-aids in to get things working or keeping comfort or temperature for people. They're also the ones that, unfortunately, they understand where the deferred maintenance has been, where they've been able to band-aid it to keep things moving along. And so they're critical for your ability to understand how are our systems working? How are they intended to be working? That's part of that analysis, right? And then the building operations is different because those are the individuals that are making decisions for how many people are going to be in our building. What kind of traffic patterns are we going to have? Are we going to allow, and you look at different facilities like universities where they have a lot of different activities on their campus and their building. Are you going to allow musical practice, band instruments, right? There's a lot of studies on that, or choir, where you're actually exhaling more. And so, you look at those kind of things and how cafeterias are going to be done, or in a K through 12 school, more times than not for busing, you always see the kids would always just line up and they'd all be in this big piece. Well, they have to be involved in making sure that you're not there collecting, or you'd have to understand, okay, we're going to collect 1,000 kids and put them in a gymnasium until the bus comes. Well, that's a huge high risk. So the building operations are going to really help you understand what different areas you would need to focus on during this analysis, right? And so you're going to, like I said, you're going to analyze these systems. Step one, it kind of is a little bit of a tactical commissioning kind of effort. And so you want to gather the documentation on that building, what's available, right? So we always say, hey, do you have the most recent record drawings, as-built drawings, or have you compiled all your different renovations over the years and you have one common set? Typically you don't, but you just want to find those drawings specifically on the HVAC so you can take a look at what's in there, right? If you can get some equipment submittals for air handling units and other pieces, that can help you. If you have test adjust and balance reports, that'd be awesome. Gives you a little insight as to, at that point in time, how much air was coming into the building from outdoor, what pressurization is in the different spaces, and any commissioning reports, right? And you're going to use this just to familiarize yourself with the building, with the systems. What are you getting into analyzing? So then you have to actually physically go and look at things, right? This unit, Dennis Knight is actually in the field evaluating a unit for one of his customers, looking at the filters, looking at the coils, trying to see, at this point, you're trying to see is, are there other issues that would prevent the system from operating correctly, properly, being able to increase your outside air or add extra filtration. And so you're going to be looking at your different systems, right? This one, this building is mainly pneumatic to a degree, and this one, yeah, but so this one here is this exhaust fan, leave on hand, let it run all the time, right? So you can tell it's going to be on all the time, and the exhaust fan next to it, it was on the ground, so it wasn't as good of an image. This is of an actual built-up air handling unit with MERV 13 bags and some cartridges underneath, and you want to look at your coils, and in this case they actually have you can see these bars going across. This is UVC that was installed for surface disinfection of the coil and the drain pan, not for the single pass and activation. But you're trying to look at this to see, could you add UVC? Could you take these shields off and get some things? So you need to go and look at these systems, right? They're all individual systems. I kind of liken it to the auto industry with, cars, trucks, motorcycles, makes, models, and then options. It almost seems infinite, right? And so think about all the different HVAC systems that you've seen, operating as a system that are completely different, and you'd have to address them differently, right? So if you've got a DOAS unit that's pushing outside air in, and then you've got chilled beam or radiant heating and cooling in that space, well, you would do different things if you had a normal, 10 to 20% mixed recirculation air handling unit feeding VAV boxes. It's different systems within the space, feeding the space, and overall. And so you'd have to use different mitigation strategies. And so you have to understand this. If it has a BAS, right, had some under pneumatic, which makes it interesting, But if you're gonna update this, just some quick things, which is save it, back it up, record all of your set points, make sure you have how it was operating before you made any adjustments in case you need to go back, including the logic. And then, a lot of this time during this was, if you don't have remote access to your BAS, a lot of individuals are working on reduced maintenance staff on site. This would allow them the ability to look at their building, make sure things are working properly, and allow you to check it. So just a plug for the ability to do that, and how much more individuals could look at your systems and see what's going on during this process. No one likes to talk about it, but deferred maintenance is huge. It's actually, we've got a client where their deferred maintenance is at a point where more than 50% of their equipment is past its expected life span. And so now they're trying to figure out how can we evaluate these systems and operate them during this time frame, and they've got a lot of old equipment, right? So you have to talk about that deferred maintenance, right? Some of it was because they were shut down or they were very little occupied, and so they weren't doing the ones, through Q2 and Q3 of this year. Some of it is due to budget, but you have to understand where those are, because, it's funny. One of those things is, a system that's operating and bringing in ventilation or outdoor air to your building is better than a system that's broken because you tried to go to a crazy MERV level filter or add all these other components. And so you need to understand the quality and where that is, and where those skeletons are hit. And then you want to look at all the different sequences of operation with it, trying to figure out, can you add in modes of operation? The alarm settings, this is one of my favorites, is, you go and when you analyze a building that's, for retro commissioning or existing building commissioning, how many times have you gone in and the filter alarms, they're not turned off. They're actually, the timer is set to the maximum, 9,999 seconds. And then the set point is set to something that it would never hit, right? It's a MERV 8 filter, and somehow it's got to hit 2 inches of static pressure to initiate alarm. And that is done purely to avoid nuisance alarms, because, oh, we change our filters, quarterly or however often we do it, and I really don't want those alarms. And so those systems have adjusted. Well, in this mode, in epidemic times, I surely want to know if my filters are working, right? If I've got actual differential pressure sensors, not switches, you can tell if a filter's been sucked in because the pressure drop has gone so low that now you don't have good filtration for your system. So you want to look at those alarm settings, right? And then an emergency mode, a unit fails and it shuts off and I have no ventilation. After how long do we want to make sure that, are people still in that space? Should they be leaving? Is there other measures in place to take care of it, right? So we did this for the ASHRAE headquarters, the old headquarters. They just relocated. And we were fortunate. We had the original commissioning provider. We had a few individuals with ASHRAE that were actually on the project team from the ASHRAE side and understood the project as it went. We had the facility operator, if you will, in terms of the individual that was in charge of the building and the people there, as well as the individual that was in charge of all the maintenance and overseeing it and interfacing with their service companies. And so we, this was in late April, early May, where basically everyone was on lockdown and no one was going anywhere. And so we did WebEx and we looked at their live BAS and we looked at drawings and we had these conversations, right? Like I said, we were fortunate we had people that knew it and we would like to go out and look at the systems. But what we did is we walked through and said, okay, what could we do to improve this? Are there any potential failure points? And so you can see they have a DOAS system. And as we went down, we started looking at all the different things. And so this first one is, they've got a couple cooling circuits that have had issues. And so we said, hey, you need to get your service contractor out there to look at that, right? That's a deferred maintenance. You lose cooling, you lose the ability to maintain comfort. And created this entire list, kind of a work plan to fix issues and implement mitigation strategies. And so then you have that work plan, you've got to communicate it, right? And I love this image because it's a blank puzzle, right? Every project is slightly different. It's always a new puzzle, but in reality, that puzzle is going to change as you fix things or you find things, right? Because you might write something on a work order and one of Justin's guys or Troy's guys go out there and they go and evaluate and they take readings and they go, you're not going to get there, right? So you need to come up with a new plan or a new strategy. And so it's a constant rework of what your plan is. And you got to have great communication when you're doing that. And that's also communicating to the occupants. And then you just have to go through and fix things and check things that the things that were going to be fixed have been fixed. So, you know, from this point, you've analyzed your building, you've looked at different mitigation strategies. Like I said, they're going to dig deeper. And then you build this building readiness plan that is, here's our plan of attack of how we're going to operate the building from an HVAC standpoint, as well as non-HVAC measures. With that, I'm going to turn it over to Justin. He's going to get into some ventilation.
Great. Thanks, Wade. Hopefully everybody made good notes, because there's going to be a detailed exam at the end of this for all that great information that we just heard from Wade. Hopefully my part and maybe Troy's part, we're going to be talking a little bit more in detail on just specific items that were part of the building readiness, namely increased ventilation and those strategies. I'm going to go through these items, which is going to be ventilation control, space pressurization, and some of the challenges that we need to be cognizant of as we start making some of these changes. And then talk about what ASHRAE is recommending through these resources in the standpoint of building flushing. So, all right, increased ventilation. It would be really nice if throughout the country, or the world that is, that we could just open up and blow 100% outside air through all these buildings and have 100% ventilation, and everybody would be happy and everything like that. But unfortunately, that's not the case. If you're not in one of the beautiful areas of the world where you can just open your windows all the time, then you know what I'm talking about. It's either really cold outside, or it can be really warm and humid, especially down here where I am and where Wade's located. During the dead of summer, you definitely don't want to bring in any more ventilation than what your system can handle, because you're going to get into some humidity issues. So there's a few things that we need to worry about when we start increasing ventilation. ASHRAE's building guidance says that we need to try to increase ventilation as much as possible, because the research has shown that increased ventilation does help to dilute and reduce contaminants and these and potentially the virus in the air. And so it's a good idea, but unfortunately we get into some limitations when we start to do that. And namely, some of these are our fan system capacity. In certain instances, you may not have the capacity in your outside air system to bring in more outside air than what you do now. Or more likely, you're not going to have the capacity to heat or cool that air, or control humidity, even if you can cool it. And then beyond that, you've got the maintenance considerations with bringing in potentially additional contaminants and things like that from outside the building, even though we're trying to reduce the contaminants inside the building. So I'm going to touch on these a little bit more. Wait, if you can go to the next slide. All right, so what are some strategies we can use? Actually, I want to back up one. When it comes to ventilation, I do want to point to some of the resources that we have on the ASHRAE webpage. If you go on there, you're going to see that ASHRAE recommends trying to maintain between 40 and 60% humidity in the space. And so it's real important, as you start implementing some of the strategies that Wade outlined in his slides, that we keep that in mind. I think what the team here is really advocating is, yes, try to push the envelope a little bit, but make sure you have qualified folks and you're monitoring the situation. And it really comes into play on the thermal and the humidity control. And you've got to have somebody that knows what they're doing, and they're really watching the building, be it a test and balance firm, be it a commissioning provider, be it some really good BAS trending and things like that, and a skilled building operator to really keep an eye on these things, because you can create other problems, as we all well know, if we go too low, or especially too high on the humidity level. So, but if you want to see a good example of that, I would encourage you to go to the ASHRAE resources. There's a good example that kind of talks about how much you have to increase your system capacity when you start going up in increasing your ventilation rates. Wade, correct me if I'm wrong, but I think you pulled this from over in your area, which is almost tropical, just like here in Houston. So But it's pretty interesting if you're not used to looking at those increases in capacity. I encourage you to take a look at that. So if you can, go ahead and go to the next one, Wade. Got a little ahead of myself there. So let's talk a little bit about how do we increase it. Obviously, we talked about what are the things we need to consider from a limitation standpoint, the things that we need to be cognizant of when we start trying to implement these strategies. A lot of folks are going to go, how do I do it? Do I need to go in and completely reprogram my BAS? Do I need to have a tab firm come in and we're just going to open up all the dampers? Let's just command everything wide open, command our return dampers closed. That's probably the worst thing that you could possibly do, except in maybe certain select areas of the country. And so the committee, in going through and looking at this, put some suggested strategies out there. By no means are these the way to go, but they are suggested ways to handle, especially from an automated standpoint. If you have the capability in your building automation system to monitor humidity, monitor discharge air temperatures, monitor space conditions, and like I said, you need to be able to monitor humidity in your spaces to be able to do at least some of this. But essentially, it's pushing the envelope on your controls until you see something go out of control. So you essentially increase your outside air set point or your damper position for your ventilation control until you max out the capability of your coil, at least from a standpoint of trying to control the sensible set point, which is about all you can measure on the discharge side of a coil, or at least that's how most folks measure it. But in doing that, you got to be real careful of what's going on in the space as well. And you may be able to maintain leaving temperature on your coil, but you may still have somewhat of a humidity rise out in the space. So it's important that you're going through and you're looking at what's going on in the space, and you reset that set point if your humidity starts getting too high. And so every control vendor is probably going to have a little bit different strategy. I'm not going to go into the nuances of every system, but essentially you're putting this on a reset until you see something go out, and then you're gonna start backing it back down until you get things back in control. And that's just a way to kind of automatically try to accomplish some of these strategies. There's obviously many others. There's the much more of an engineering approach where you can. I'm going to talk about in the next slide some flushing strategies and things like that. But that makes the assumption that you've got to be able to actually measure some of your airflows, or have a good idea. You got to have a tab firm come in and measure what you've got going on, and we're certainly advocating that. But this is a simple way to do it here, just off of temperature and humidity. And then if you want to go into a more complex strategy, Wade, if you don't mind, go ahead and go to the next slide. Well, I'm going to get there on the next one. I'm sorry, I'm getting ahead of myself. I want to talk about some of the limitations if we do this, okay? If we start increasing our pressurization in the space, we can cause other issues outside of humidity control and temperature control. And some of these, if your building is not set up to have good relief, it's not set up for excess pressurization, things like that, there's a lot of other issues that can be caused. Namely, you can blow the front doors open. That's a simple way of saying it. You can cause a lot of excess noise and things like that. And if you have a high-rise building or a building that has vertical transportation type systems, elevators don't do well when you start trying to transfer all the air through the elevator shafts. And oftentimes will throw off those areas. The other things that can happen, we have pressurized areas in every building. Obviously, in healthcare and critical environments, pressurized areas are the way that the buildings operate, and they're designed in that fashion from a safety standpoint. But we have that in a lot of other areas as well, namely commercial kitchens, restrooms and custodial areas and process areas. All those areas are designed under current codes to maintain certain pressurizations, certain ventilation rates. So if we go through and we start increasing ventilation without a strategy, without an engineering mindset, so to speak, we can in fact throw these areas off, and you can cause an area that you might have wanted to keep negative, and cause it to be positive. And that would kind of defeat the whole purpose. We're creating a separate set of issues. So just be mindful of that as we go through and try to achieve some of these strategies, that we need to keep in mind the original intent of the building, and really put some thought into how we go about implementing these strategies, and really watch what's going on overall. I can't say that enough. So go ahead and go to the next one, Wade. Now I'm getting to what I was trying to bring up earlier. So when you talk about the flushing strategies, if you go over to ASHRAE's guidance, what they're advocating is essentially, these complex calculations here talk about air changes and what it's going to take to reduce the contaminants by 95%. And essentially, based upon these calculations, the recommendation from ASHRAE is to try to have 3 complete air changes in the facility. Obviously, we know that may not be able to be achieved, but one of the ways that they're advocating this is to do a building flush. Okay, and these calculations, at least to someone that doesn't do them all the time, look a little scary. There's some calculus involved here and things like that, but I think that the real point is if you can figure out the volume of your space, and you can figure out, it's fairly simple calculation to go through and figure out what is it going to take to turn over the air in that space 3 times, and it doesn't have to just be with fresh air. I think this position was actually amended a little bit, and Wade, he can kick me if I'm wrong here, because he knows more than I do on it. But what ASHRAE actually says is 3 air changes of outside air or 3 equivalent air changes. So if you go through and do some of the strategies that Troy's going to talk about next with some of the filtration, you're effectively getting some air changes, some additional air changes there without utilizing outside air by using filtration and potentially other strategies. And so what they're advocating is 3 either way. So it's 3 equivalent air changes of the entire space. And sometimes that's going to be tough to do. Sometimes that's going to be tough to figure that out. Maybe tough to measure it and things like that. And so in light of that, ASHRAE's come back and said, if you can't run these calculations, you can't follow this to a T. What they're recommending is a 4-hour flush period. It's basically 2 hours pre-occupancy, 2 hours post-occupancy. You're probably going to be going a little overkill there in most buildings. Again, this is by and large just across the board, standard commercial buildings, K through 12 schools, just regular occupancy with standard ventilation rates. But if you can try to meet those recommendations, it's definitely going to help. Is it going to eliminate any kind of contaminants? No, it's not. But these calculations and the research that's being conducted shows that it should dramatically decrease any standing particles. And Wade showed that great picture earlier of the restaurant, and that's what we're trying to mitigate. It's just that stale air that is potentially contaminated by occupants that's just being recirculated over and over and over again. And so that's what these strategies are trying to mitigate that, trying to flush all that out amongst all the other things that we talked about in that great triangle that Wade showed earlier. It's engineering controls is only one strategy. So with that being said, I'm going to reiterate what Wade said earlier. A key to implementing, especially this part, is you've got to have a good team. You've got to have either faith in your BAS because it's been verified by qualified individuals that you can trust your airflow monitoring stations, your temperature and humidity instrumentation, or in the lack of that kind of confidence, you really need to bring in a good team of test and balance folks. I realize most of the folks that are on this call probably are in that space. But this is something, normally I'd be standing up in front of all the AABC members saying, we need to do this, we need to do that. But this is somewhere where, to all the test and balance and commissioning providers out there, this is the value, this is the service that we need to be selling to our clients. And hopefully the building owners and engineers, and hopefully we have a number of those on this session, realize, this is one of the areas where a test and balance firm, good test and balance firm, commissioning provider can really assist, and even design engineers can help with these strategies, because as you can see here, it can be very, very effective. So I'm going to go ahead and turn it over to Troy now and let him talk about the next piece, which is filtration.
So just one clarification, because this literally got changed the end of last week, beginning of this week. The and is now an or. So it's 4 hours pre or post. And that's, if you don't do the calculations. So.
Thank you, Wade. Thank you, Justin. I'm going to go ahead and give you my punchline, which is reiterating what Wade and Justin both said, just so that you can hear this repeated. I think it is very important what Justin just shared with you, and I can't think of a better topic to share, to shine a bright light on this opportunity of collaboration. And when you start talking about making changes to these systems, in most cases we're going to increase the energy consumption. So it highlights the need for the energy management professionals and everyone's role that's been described. And so when we think about the EMA and the ACG and the AABC, we're describing ourselves as the authorities in building performance. And so this just underscores the need for us to reach out to other member firms. There are 600 member firms in those associations, to get together and collaborate so that you can have a successful outcome without leaving gaps in the study and in the results, so that you leave the building after your study and after your approach to making these changes in a completely operable condition, with comfort inside and equipment that's not stretched beyond its capacity. So on the filtration side, obviously we're concerned about capacity as well. And we're going to talk about increased efficiency. And when I say efficiency, I'm talking about the MERV rating. So minimum efficiency reporting values. And that's a little bit of a misnomer to me. When we talk about efficiency, I start thinking we're going to have a little bit easier time making this happen. But as we increase the MERV rating, then we're actually increasing pressure drops across filters. And we'll talk about the MERV ratings a little bit more. We'll talk about the importance of the field readings prior to upgrading the systems in the filtration and post-upgrade, and find those results, find our capacity point, operating point there without exceeding capacities. We'll perform some analysis, and then we'll talk about some post-pandemic tasks if we're returning the system back to normal. Next slide. So MERV ratings. So just to review that, ASHRAE came up with the MERV rating system in 1987. You take a MERV 8, you're basically saying you're going to catch some of the particulate. MERV 11, you're going to catch more. And a MERV 13 is a quote unquote catch all. This is what's recommended in the face of COVID-19, recommending MERV 13, preferably 14. But of course, we're concerned about the pressure drops, but this is to try to remove those particles in that 0.3 micron to 1 micron diameter size. Of course, with this, we've got to be certainly careful that the filter installation is clean and that we don't have gaps. So we're going to talk about light testing and making sure that we don't still allow those particles to come through, even though we've got MERV 13s installed, but having gaps in the filters and the proper sizing of the filter racks and the spacing of the filters with regard to the unit casing, so we don't leave any gaps there. Okay, and so ASHRAE's done the studies here, and this is what arrived at the MERV 13 recommendation. And you can see descriptive statistics of the pressure drop data there. In some cases, we don't see a large difference in pressure drop for a given airflow, but that's going to be dependent on each manufacturer. We need to look at each manufacturer's data, and then again, the field testing is going to be very important here. Okay, slide. So we're going to start with data gathering, and of course, some of this is what we talked about in Wade's presentation with the overview, but with regard to filtration, the original tab report could have some very good information. And we're talking about from original construction. So some of this data could be quite old. Some of the equipment could have changed out since then, but we still want to start with that to try to find a baseline for when the original equipment was originally designed. Okay, so with that equipment, we're looking at the submittal for the, let's say, the air handlers that are involved in our study to see what they were designed to perform as far as static pressure. The original tab report tied with the submittal could give us the original operating CFM delivered by the unit at a given RPM and amps. So we may already see, where we were with the equipment as far as capacity for increased RPM, for anticipating increased filter drop. So where were we on the fan curve there? And do we have a static profile for baseline? And are we going to have to, recreate that in the field to see where we are today? And in most cases, we will see that as equipment's been operating for a while, that static pressure profile is going to change. So it's pretty important to go ahead prior to upgrading the filters and get a new static profile, get a new, airflow for the system before we even consider or contemplate going to a higher MERV rating. Okay, so with the size and thickness of the filter manufacturers, with the filters, we want to make sure that what we're replacing and moving forward in upgrading will still fit in the filter rack, or would some modifications be needed in order to make any changes. So at this point, once we've reviewed this data, we're going to walk the site with the stakeholders, and this is the building operations and facility managers on the team. They have so much information, and especially if you have the BAS contractor there with you, perhaps the original tab team on the project. So building operations, have been modified over time, perhaps. They can let us know what sorts of Band-Aids that they've been putting on the system, what sorts of occupied, unoccupied mode they're already running in and for what reason, how they're using their spaces and so forth and so on. That all needs to be considered when we're making any recommendations. Any areas that they're having trouble maintaining temperature and humidity already, we certainly don't want to make those matters worse by any changes that we're making. So we talked about the filter gaps. So once you get to a unit and you're checking it out, this would be pre or post. We want to see if any of the air is bypassing the filters. So if you can get on both sides of the filter, you can perform a light test. And if you're finding that that we're having trouble, getting a tight fit within the filters, some of the things we can consider doing after the upgrade, or if we're going to maintain the ones we still have, is to tape those filters, on one side, so that we limit that bypass air. So we don't want to defeat the filtration in place and let that, let those contaminants still pass through. So we're going to document the static pressure profile as found and measure the airflow with those existing filters. We're going to record the fan and motor RPM, amp draw to see where we are. We're going to look at that equipment submittal that we've hopefully found by now, and a lot of that's available online. And we're going to see if we're going to exceed any, maximum RPM before we make any changes. We're going to make sure we're not exceeding maximum amps, and we may even consider operating at somewhat of a reduced airflow if we can achieve the filtration goal that we're looking for. Within 5% is what ASHRAE would recommend. Let's go to the next one. So once we've got our filter rating determined, we've got our new unit profile with the filters installed. And as I said, if we're less than 5%, we'll maintain there. If we do need to increase, we're going to try to get as much air as we can with the filters that are desired. And then we're going to start looking at the sequence of operation of the units. And this goes more into what Justin was talking about as far as maintaining ventilation. And so we're going to establish the pre and post occupancy schedules, and that's going to drive those air changes. But if we can't get the higher MERV level filter that we want, then there are also other means of driving that effective air change rate that was discussed earlier. So you might consider bringing in portable HEPA filters. And so we're still, filtering that air, but not through the air handler. But there are other strategies there. And then if we find that we need to go into, a further analysis, then we want to bring in a design professional to look at new fans, or if electrical changes need to be made, things like that. But as a team, everything needs to be documented, each step. So it's sort of an iterative process that you're going through, finding the as-found conditions, making those recommendations, making those changes, and then documenting what happened next. And there's going to be another round of recommendations to see where we finally end up with the full program, we'll call it. Okay, next. So here's an example case where they took a filtered level from a MERV 8 to a MERV 14 to achieve a supply airflow or maintain a supply airflow of 23,000 CFM. Fan RPM increases there, 2216 to 2395. We ended up with a 1/2 inch greater pressure drop at the dirty filter level. That's, if you can't see that, it's 5.3 to 5.8 inches of water gauge. And the brake horsepower increased from 5 1/3 to 6 3/4, we'll say, with a nameplate horsepower of 7.5. So in this case, we did not exceed the motor nameplate horsepower. But again, if we were approaching that, then one of the solutions may be to just reduce the airflow, maybe achieving around 22,000 CFM and still maintain the desired conditions in the space, but not exceed that brake horsepower and not, reach into some excessive, replacement project where we're talking about upgrading electrical service and things like that. So we do have to look at this from all angles to figure out, there's not a one size fits all. And we certainly don't want to see, building owners just throwing in upgraded filters without having, data available, measured data for each case, so that we can, guide them through that with various, options. Okay. Post-pandemic, this is just something that might show up in a building readiness plan. That once things go back post-pandemic back to normal, if we are looking at more energy saving, strategies for the system, we just need to consider the total airflow and static pressure is going to change again. So we need to sort of do the pre-change and then the post-change. And if there are any modifications were made to the filter rack, things like that might need to be changed back. If we had to change them to modify to accept the new filters. Of course, you might want to hold on to those things for the next, situation. And so we store those for future use. And really that would wrap up the whole cycle of taking a building from, pre-pandemic through the pandemic and then post-pandemic. So I've already given you my punchline. I know that you can see the team players that are involved here. Can't stress that enough. There's no one individual that can come out and just look at a system or even measure a system, but come up with all of the recommendations that are needed. And filtration is just one piece of this puzzle here. So I think that wraps up my slides. Justin or Wade, did you have anything to add to that?
Sure. So I think at this point, Ray, you're going to come back in and.
Yeah, if we're ready to go, then I'll just note for all those in attendance, we do have a handful of questions in the queue right now, but we've got a good solid half hour with our 3 experts here. So if you've got questions on your mind that you haven't entered yet, then go ahead and use that Q&A button at the bottom of your Zoom window and submit those. So I'll get to the questions that already came in. For a cold climate location entering winter, how would you prioritize increased ventilation reducing space humidity versus minimizing outside air to maximize space humidity. Keep in mind that getting up to 40% relative humidity levels are a significant stretch for systems in cold climates. And I
Justin,
think,
you want to?
Justin?
Yeah, I mean, I'll give a take on it, and I'll let Wade or Troy chime in. I think you bring up an interesting point, and yeah, it's a double-edged sword. It's tough. So what's more important, right? Is it more important to provide the 3 air changes of the facility, or is it more important to consider other strategies or problems we could create? This is the opposite of what we deal with down where I am, but it's definitely relevant because you can create some significant other issues in the cold climate. My response here would be, go through and see what you can do with the system. You need to know both in the heating and the cooling mode, what can you do? And given that we're going into the cooling season and this pandemic is still active, and I don't think any of us know when we might be able to breathe a sigh of relief that it's on the downswing and out of here. I think you need to know where you stand, number one, know what you can do from a ventilation standpoint. But at the same time, maybe the full ventilation or outside air ventilation is not the key. Maybe the key is to look at the filtration side. And as Troy just touched on, it may not even be the ventilation or the filtration in your system. It may be localized filtration. And that may be the best that you can do. And I think the key to it here is, the committee or the task force has made a lot of good recommendations, but the task force also recognizes that every building's different. And I think the key to it is you just need to do something. You need to do the best that you can, and then take into account all the other strategies that are happening, from occupancy to PPE to all the other things that are going on in the facility, and just maximize the situation. But that's all that I can say. I mean, Wade, Troy, you guys want to add to that?
Yeah, Justin, I think it's very similar to the humidity issue that we were talking about in Florida and Texas. And, you really have to look at the capacity of that system, take it as far as you can, but then use the other strategies to gain that effective, filtration and air change, ratio.
So it's an interesting question. And that's, when a lot of the guidance was initially built, it was, April, May, rolling into summer for most locations kind of thing. So the heating side is getting built up now as we speak. So what ASHRAE's core recommendation is to achieve code minimum ventilation and the equivalency of MERV 13 filtration. And so they actually, and that's where, when I mentioned about the task force, the scientific application team is trying to do different research on just that, which is your question is, okay, if I had 40% RH, which I completely agree with you, that there are many buildings that would cause far bigger issues to have 40% issue with your thermal gradient and your walls. So you have to analyze, can I even do 40% in my building, right? Let's say in the situation you can. Then you have the scientific application team is saying, okay, at 40% RH and code minimum outside air and X amount of filtration, what level of protection, what performance am I getting in terms of capturing or inactivating the virus, right? And then you run that same scenario for, okay, at 20% RH, and what the RH does is it shows from, I think it's Department of Homeland Security has a calculator that you can use for surface and or air half-life of the virus. And you can see at 20% or 20 some odd percent, it's much longer time frame for that virus half-life than it would be at 40%. So, and then you look at that and say, okay, what is that overall impact that I'm going to have for my system, right? But I think your starting point is code minimum ventilation and the equivalency of MERV 13. And so in your case, if the building could, which we said had to be checked, do 40% RH, it's likely that you're probably going to do code minimum with MERV 13 and try and maintain that 40% RH. But that is specific to that building, that system. Hopefully that answers your question.
Great. And guys, I think you're following along, but we've got a full dozen questions in here. So just keep that in the back of your mind as we're answering a lot of great ones flowing in.
Yep.
Given that tab specialists or technicians working in the field are exposed to air handling unit, return air streams, testing common surfaces, filters, etc., do you think they are at an increased risk compared to other HVAC service providers? Maybe Troy?
Yeah, I'd like to take a shot at that and ask Justin, their experience as well on the tab side. So I don't know about an increased risk, but I think that it is important to talk about safety and PPE right now, because particularly with regard to filters, which was, my focus in this today, if we're working with filters that obviously are trying to capture, contaminants, including, virins and stuff like that, then, we should be taking care not to, pull a filter out of a unit and, go walking across the K-12 classroom to take it outdoors to, throw it away, protection for, the technician, protection for, the space around us, getting that filter into a bag, and not allowing any of that particulate, to come off that filter, wearing gloves so that we're not, touching that. So if we're in there, touching things and working with filters, changing out filters to compare a MERV 8 to a MERV 14, but now it's, been in operation, then we definitely need to take some PPE precaution.
Yeah, I'll add to what Troy said. I mean, are we at an increased risk to other HVAC service providers? Yes and no. I mean, it depends on the nature of the work that you provide. My company works heavily in the healthcare space, and I actually have folks making changes to rooms next door to rooms that house patients with COVID, and so. We're following the recommendations of the facilities where we're working. We're following the CDC guidelines, with the use of PPE and things like that. And then we're just using common sense, and wiping down tools, wiping down surfaces, and just trying to do everything that we can from that standpoint. And I think that's the key here is do everything that you can. Exercise at every level of caution that you can, because it's just not worth, having your work potentially cause this virus. And I'm going to knock on wood when I say this, but we've been fairly successful in this, so far, because I think you look at the number of service professionals and things like that have been working on these systems. I haven't heard of dramatic increases or spikes in cases related to that. You hear about healthcare workers, you hear about other folks, but they're right there with the patients in the breathing zone. And I think the key to it is that we just need to be smart when we're working in these areas.
Thanks, guys. How effective is using bipolar ionization in the air handling unit against COVID-19?
So I'll respond understand you have to wear two hats, right? So I'm responding as ASHRAE based on the Epidemic Task Force. Wade Conlan, as a professional, has used them. So I want you to understand that I've used them in different situations, not for COVID-19. ASHRAE has been getting a lot of questions on this. And so one of the things they did is they actually reached out to CDC to get an opinion and or a position from them on bipolar ionization. And what the CDC came back, and you can see this actually in the filtration and disinfection guide, the actual statement quoted from CDC, which kind of lumped this into an emerging technology. And they said, step one is to make sure that it's not generating ozone. And so the UL 2998 certification, which is no more than 5 parts per billion, it should be part of the product. And the main players of this in this market have that certification, but you need to check, right? The next one was that they weren't going to make a decision on a specific technology, but what they said is you need to look at the research that's been done, right? And a lot of people say third party, peer reviewed, whatever. Just look at the research that's been done, and how does that apply to the situation you're going to use that device in your facility, right? And so manufacturer one, if you will, has done research, and they're all doing research, and they've done research on and the one that has been most prevalent and put out there and people are seeing was for aircraft. And depending on the density of the people in that aircraft, but aircraft typically has 20 to 30 air changes an hour, where most offices and schools and et cetera, you're looking at 6 or 8 at peak design. Aircraft also has HEPA filtration, which is 99.97% at its weakest point in terms of capturing items. Most schools, offices, et cetera, are currently, unless you're in California and others, is your LEED certified, is you're at a MERV 8. And so that is a completely, now even if we bump to a MERV 13, that's still not HEPA. And so what you have to then take is, if that research has been done for that system in aircraft, how does that relate, or how do I correlate that to my office, my classroom, et cetera? I can tell you personally, I have asked that question from a couple manufacturers saying, I see this study, this is great, I'm glad you've done it. I don't have aircraft, I have classroom, I have office, I have schools, I have, whatever different, it sounds funny, but the airport itself. And so how do those correlate? And I have not seen those studies. Another thing from the ASHRAE perspective is there is not a method of test for these devices. And by that, ASHRAE has a method of test. Yesterday, Tom Smith talked about the standard 110, which is a method of test for performance of fume hoods. Well, that's just a test that shows you how to do it to get results, so you can compare results from one to another, liken it to the auto industry. My car has a highway rating for miles per gallon, just like Justin's or Troy's. It's done the same way. So we can compare them and see those numbers. That method of test does not exist for this device at this time. So how can you compare one to the other? And so what CDC eventually said is it's up to the engineer to understand the research that's been done, how it applies, and make sure that it doesn't generate ozone. Now, that's ASHRAE. I can tell you I've used it in my home. My son has severe allergies, and it has helped collect particles. So if this is collection of particles, and some others say, and some that they generate other particles that you're not impacting, but I can tell you that it has greatly helped my son. So in fact, of it with the same filter level collecting more particles, I get where that would have a benefit. As far as it inactivating the virus, that's not something I'm willing to even talk about at this point. So hopefully that gives the run of the answer. I don't know if Troy or Justin, we want to jump in on that, Rain.
You got it covered, Wade.
Yeah, I think you did a pretty good job.
So.
Great. Next question. What additional liability might a tab firm be taking on when recommending mitigation strategies and calculating flushing and air change rates? How should a tab firm offer that service without taking on extra liability or even crossing into design services? Justin, you want to lead?
I'll take the lead on it.
I think we're both going to say the same thing, Justin.
I think Wade can as well. We have a saying here at EAB, and when I get on the soapbox, I think my guys, just like Charlie Brown, they just go wah, 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 wah. But we don't make recommendations. We make suggestions. Okay. And because we're not design professionals, at least a tab firm and even many building commissioning providers, that's not our role on the project. That's the design professional or the owner's role to make those decisions. And so you can be part of the process. You can certainly make suggestions. You can give input and data and lend expertise. And we certainly call upon in many instances to do that. But I think as long as you don't assume that role and say, this is what we're going to do, and this goes across the board, not just in these strategies, that's anywhere. As long as you don't take on that role and say, maybe I'm a PE, maybe whatever else, or I'm a certified TBE, I'm going to take on that role and I'm going to tell you, you need to change this, and this. That's when you cross the line. And that's where we've got to be very careful, because I'll acknowledge we skirt that line sometimes, but ultimately the decision has to rest with someone else. We're not the ones making the decision. Wade, do you want to add to that?
It's the flip side, right? So I'm not certified to do test and balance. I can go take some readings, right? I've used some of the tools. Am I proficient? No. Am I certified to do that? No. But can I do enough to get a feeling for it? Sure. Now, if I want to actually give a true recommendation or state a fact about airflow and different measurements, no, I cannot make that statement, right? So it kind of goes in the reverse of, that's why you have to work as a team.
Yeah, and I'd just like to echo what Justin's saying, because we have that conversation all the time between our tab guys, commissioning guys. If we're forming an opinion, then we're practicing engineering, right? So we don't want to form any opinions or make those recommendations. But if we have a design professional on board, and this is why it's so important to build that building readiness team that includes all of the professionals for their given roles, then it's a whole lot more comfortable going in, and it's a whole lot more comfortable walking away for each participant, knowing that they had the professional, in charge of that particular area.
Great, thanks, guys. Next question. What is ASHRAE's opinion on inline devices such as REAM that use hydroperoxide plasma and zinc ions? Cruise lines, some schools and hospitals, military, and others are using them. And China used against the SARS virus.
Yeah, so those are also those are listed in the ASHRAE's filtration and disinfection guide. It talks, like I said, it talks about a lot of the air cleaning technologies. Dry hydrogen peroxide or the photocatalytic oxidation are two that are covered. Once again, they fall kind of under that emerging technology. And believe me, I hope they work. I want them to work. But you have to then, as an engineer, evaluate that same thing, right? A lot of those, when they're tested, the testing facility, if you will, is about the size of a beach cooler. I'm not saying that you can't extrapolate that out and turn that into a full-size space. But once again, that's where the engineering guidance needs to come in. I can tell you that I've used dry hydrogen peroxide, which you can breathe in, not for COVID, but for a different reason. And I know they are deployed in a lot of locations. And I know that a lot of these places or these technologies are doing studies to try and show that they are effective against the SARS-CoV-2 virus. But as far as ASHRAE is concerned, that it is still a newer technology. And what's interesting with that is individuals that have been part of it. One of the individuals made a statement of, this is, compared to bipolar and others, this is where UVC was 10 plus years ago, right? They were still having to prove itself within the HVAC market. And they built a method of test and other things that go along with that. So not saying they're not effective, but that's where ASHRAE stands on it.
Guys, you good with that?
Yeah.
Okay.
Wade's the expert in that area.
I figured we had the right man for the job there. Next question. Are there any thoughts on the correlation between reduced occupancy and reduced internal heat and cooling loads, allowing added ventilation and or lower flow rates for better filtration?
From a design perspective, absolutely, right? So if your occupancy, like I said, my office at 50%, that's 50% less people in there. There's less load. So could you potentially use some of the strategies that Justin showed to increase your ventilation or outdoor air to the building? Absolutely, it will help. What you have to remember, though, is we're not just trying to remove a contaminant. Like, we're not in a facility like a clean room where you're trying to keep things, all particles down to a certain level. We're trying to operate these buildings to mitigate a virus. And so one of that way is through flushing. So some people say, I've got less people, I'm going to reduce the amount of outdoor air beyond the design minimum because I've got less people. Well, the intent is that your system can handle that load, can handle that amount of outdoor air. And yes, it is more than the normal occupancy, but it does help remove contaminant. And the equipment is sized to handle that. So some people also ask for that is, could I then reduce my outdoor air because I have less people? And that it goes against the intent of trying to take away a virus, remove a virus from the space. So that's Justin, Troy.
I agree with Wade
Yeah,
there.
I agree with you, Wade. I think that's, look at each situation, but yeah.
All right. How do you determine whether you supply exhaust or outside air to use when calculating air changes?
So
Go ahead, Wade.
no, go ahead.
Well, I'd rather you wear your engineer's hat and tell this one.
Yes, sir. And so this is where it depends, right? So when we're talking, and Justin had talked about equivalent outdoor air, right, for the flushing. And that equivalent outdoor air is your true outdoor air. So you would use that outdoor air value based on the volume to get its amount of air changes per hour that you would achieve, right? Then you would look at the recirculated air for the filter and it cleaning that air and how much air, that clean air, if you will, would then be going into the space. And if you're using a UVC or some other air cleaning technology, the impact on it as well, and using that recirculated air volume, it's kind of, when you look at the in-room HEPA filter devices, they have what's known as a clean air delivery rate, which in essence is, here's our equivalent outdoor air. And that's what you're trying to look at with your filters and your UVC. One of the key things to do that with and understand is that if you look at a system and a return comes back and I've got filters and then I go through a coil and then I hit UVC, the impact of that UVC has to remove what the filter did, right? So, because they're in series. So you can't just say, oh, my UVC on all of the contaminant in the return air. I have to actually take the contaminant out that the filter would, and then my UVC would have an impact to get you equivalency in terms of equivalent outdoor air. So in one hand, you're using the outdoor, in the other piece, you're actually using your recirculated air to figure out that equivalent air changes.
Guys, anything to add there?
Wade, I think you gave a great answer there. I think the key to it here also is, we as test and balance professionals tend to look at spaces, individual spaces, and I think that's where this is coming from. It's supply versus exhaust and offset in the spaces, and then when we're looking at more of a granular level, so to speak. And I think the key to this is you're looking at the whole facility. You're looking, or at least the occupied area, right? And you can break that down into occupancy zones and things like that, but you're looking at it at a much larger picture. And so just keep that in mind when you're there. So I think that, Wade gave a great example, but you're looking at overall ventilation and how do you achieve that? A combination of the strategies or whatever you have. So.
Thanks, guys. Next question, after outside air or filtration changes, how do you handle the question, do we pass or are we safe, from the owner or end user?
That's actually a pretty hot topic of discussion, right? There's some individuals out there that have put together some work, University of Harvard in Colorado, for selecting in-room HEPA filters for schools. And they've set their target to achieve at 6 air changes of outdoor air plus what the HEPA fan filter is. ASHRAE doesn't have that bar as a set number across the board because there's a lot of different facility types and they have different code required ventilation airflows. And so that's why it comes back to the minimum code outdoor air being delivered and equivalency of MERV 13, which kind of establishes that bar.
Yeah, and I think Justin said it best when basically put it that we're trying to do all that we can to make things better. There's no such thing as a perfect system or a perfect silver bullet, we'll say, to catch everything or make every part of the air pure. But anything that we do towards these goals will certainly help, and that's the best you can do. Every building's different.
I think the only other thing I would add is, do we pass? Well, do we pass on ventilation rates? Yeah, we can tell you that. Are we safe? I don't think there's a person in the world right now that can tell you whether you're safe or not. So That's a real difficult one. And I know the owner wants some peace of mind, but unfortunately, there's not a lot of that right now. And certainly, the test and balance professionals, not one that can give that whole designation, right?
Great. Thanks, guys. Let me jump down to, does relative humidity have an effect on the transfer of the virus? That is, does the virus transfer more or less effectively in high humidity environments?
Man, that could take a whole hour in itself, right? In essence, there's two things that the relative humidity, the virus is, and this is not all, but in this virus, it does not care for the higher humidity levels. And so it reduces its half-life. As far as it moving, I don't have the answer to that, but the other piece to it is that the higher humidity levels and how it impacts your lungs and mucous membranes, et cetera, that the higher the relative humidity, that 40 to 60%, your actual systems are better. Dr. Stephanie Taylor has a whole hour talk on relative humidity and the impact, and she gets into that. And she's actually, a health professional. So that's, I think, the best answer we could give at this point, Ray.
Got it. Thank you. Next, do you agree that the dirtier the filters, the more it could capture smaller particles? Could this be a cheap strategy to increase the filter efficiency? Justin, Troy?
I think I would stick with the ASHRAE position to use the MERV 13 and keep them clean.
Yeah. I wouldn't recommend using a product outside of the recommended application from the manufacturer or the industry. I think that's the simple answer.
Got it. Pivoting to a different kind of question, what do we see as future considerations for HVAC systems to be responsive to acute or extreme events such as this?
I think it's critical. That is why the task force was called the Epidemic Task Force, right? Is to not lose the information. If everyone remembers back, there was some anthrax scares and people started hardening their buildings and their outdoor air. And in reality, when this kind of came around, some of that, it was like, didn't we kind of do a little bit of this at that point in time? And it had to kind of be dug out, right? And I can say on the Environmental Health Committee, when SARS-CoV-2 came around, the health people, the IAQ, they're sitting there going, well, we had SARS, we had MERS, we had Ebola, we had the swine flu. This is the next one. So, and then there's going to be another one after this. And I think, I don't want to say it was a little bit shocking in the room to see their, it wasn't indifference. They knew it was very severe and had to take care of it, but just more so we've had to go through this in the past. And so I think it's critical that the guidance that we've created here does get incorporated into other things. And one of the things, and we didn't dig into it, is I've talked about it is, so when you're designing your next system and you go to do your fan system and the owner says, oh, we're going to use MERV 8s, right? That's all we have to use. That's all we want to use. Do you as a designer say, you know what? I'm going to look at the MERV 13 dirty filter level that we would probably recommend and use that in my static pressure calculations. And I'm going to let them know in a epidemic or pandemic mode, your fan systems are sized to accommodate, design airflow with a MERV 13 filter that has this as a dirty pressure drop. When you look at outside air coils, and I'm thinking of in the cooling mode, is you're starting to see two airflows now, right? And in test and balance, you guys live this all the time. When they don't show these airflows, it's tough, which is the minimum airflow. The engineer writes a sequence, hey, the damper should adjust and you minimum airflow. And they don't tell you the number. Well, that minimum really is building pressurization airflow, right? And then it should go to its maximum, which is really the design or the code minimum. And so if you start to see those two values, well, now if you say, hey, we're going to size our coils, and we're in heating mode, size our coils a little bit larger to handle some extra capacity, maybe you have a pandemic outside airflow, outdoor airflow that says this unit in this situation can handle, X amount of outdoor air. And so now that's great. The systems could be sized for that. But then your building automation system also has to be able to incorporate that. And so you would want to incorporate an epidemic mode into your BAS so that you can say, hey, we're an epidemic, press the button. you know now that your outdoor air is now being optimized, the strategies that Justin showed, or different technologies, or when you go to change your MERV 13 filters, that you know that, hey, these systems, it can go in and we're going to be able to handle it without a problem. So, but that's just mentality of a designer. But the standards and guidelines, it's going to take a while to get into code for some of these things. But I can't imagine, depending on how long this goes and how quick the next one is, that some of these are going to start to be incorporated. And as Troy said, a lot of these increase energy, right? And so we want to try and do it as effectively as possible. But at the end of the day, I think that's those future considerations. And everything, when you analyzed your building that you wanted to do but couldn't do, you need to start figuring out, is that in my design standards moving forward, right? I'm sure from the test and balance perspective and other perspective, Justin and Troy may have different examples of what would be improved or allow them to do more in an epidemic in a quicker mode, but that's what jumps into my head.
Ray, do we have time for additional talk on this? I mean, there is something I want to add to it.
We've got time. You mean about this particular question or the questions?
Yeah, the only thing I want to add to this, what we're seeing, like I said, we operate heavily in the healthcare space. I would expect to see some significant changes in healthcare design requirements and things like that coming out of this. That's the focus of this task force was more commercial buildings, things outside the healthcare space, even though there were some groups working on healthcare and really making some recommendations there. But if you operate in the healthcare area and you went through some of the things we went through, scrambling to help our clients, increase their patient capacity and things like that for folks that were infected, I think you would definitely agree with me that there's going to have to be some strategies in the future to think about this. And if we, heaven forbid, we ever have this happen again, which I don't think any of us want. There's got to be a way to deal with that in many different scenarios. And I think ASHRAE is heading in the right direction, talking about this and trying to keep it at the forefront and really working on it from an engineering standpoint.
Yeah, just to continue with that thought process there, Justin, with regard to healthcare and other areas, but I see it in healthcare. I think there's going to be more of a focus on re-entrainment. And, if you've got an air handler in a penthouse that can relieve on the north wall and has an intake on the west wall, just, 90 degrees apart, maybe we're going to look at a different strategy there for those air paths, air streams, so that there's less possibility of re-entrainment. I wish we were live. I'd love to flip that question around to Chuck Gullidge and hear his take on it.
All right, next question that just jumped on me. Actually, I'm not sure where it
I
went.
sent an answer specifically to an individual that asked a question of someone that works with someone on this panel, that we can find out his answer specifically at another time, if that moved the question on you, Ray.
Oh, okay. Could be.
Yeah, we'll take care of that one.
Okay, understood. I'm going to throw this one as something, well, that's more of a comment. You guys see one that, well, let me throw this out there because I know this has come up and maybe it's a quick answer. Doesn't the virus die with heat? Could the heat be used during unoccupied times to kill any virus in the ductwork in lieu of or in addition to flushing measures?
Yes. Yes, actually there's discussion going on if we flush and we have great MERV 13 filtration and other devices, could we close our outdoor air and how much time would that take? And look at it more from an energy balance equation than just a straight up flushing equation. I would think where I'm at, trying to heat that air up, I think it needs to be like for surface kill, it's like 90 degrees for 6 hours. Would take a lot of energy to get there, especially, or the colder climates trying to do that, to get to the point where it's killing the virus, and the amount of energy to potentially do that. And the other thing that always jumps into my head is when I first got in here, flushing was a huge issue, and you would heat the air up, but it started dealing with all the adhesives from carpet and other materials and the off gas that came from it. So that part of the flushing got out of the industry. And so I don't know. Justin, Troy, you guys have thoughts on?
The only thing I'm going to add is there are some technologies out there that are looking at that strategy. Whether they're viable or not, I guess that time will tell. But there are some folks that are looking at that particular methodology for trying to add that to some filtration. And there's been research on the I guess the biology side of things that says yes, heat will absolutely kill it. And this technology should work if you can make it, viable to actually be brought to market. And there's some folks working on that, but we'll wait and see if that ever comes to fruition.
Yeah, I was thinking of a different one, Justin, where they're promoting keeping the building at a warmer temperature for a set number of hours to do surface kill. But people, and this is great, people are being innovative. It's a matter of, can it come to market? Does it make the most energy sense? And is it really viable, or does it create other issues? And that's what you have to look at.
Thanks, guys. Have there been any studies regarding movement from standard HVAC design of using the ceiling for supply and returning to underfloor air distribution systems such that the airflow is from the floor to the ceiling to maintain a healthier breathing zone, obviously in the wake of COVID-19?
Yes, there has been. There's actually been good presentations. Kishore Kankuri did one for ASHRAE. He does a lot of CFD analysis, and others have as well. And so there's kind of two camps of this, right? One is well mixed, over the typical overhead, you're mixing the space up, moving it out. And the other is the stratified, whether it's displacement or underfloor air, et cetera. And there's two different camps of that, and it's how you look at it. What's interesting is the Wells-Riley equation that a lot of people refer to and use to figure out how effective things are requires a well-mixed space. So as far as specific to COVID-19, I think when you start to look at some of these studies, a lot of them use CFD. And for the last hour and a half, we've all been seated at our spot and that would work. But in reality, we all move around. So how many iterations are you going to do? Because each person then, your heat, rise off of you changes the air movement within the space. And so me walking and moving to another spot changes that. And so how many iterations are you going to look at? There are definitely studies that show it's effective. And there's studies that show that well mixed is effective. And I don't think that there's been a definitive thou shall do, right? If you're going, whichever you use, make sure it's working properly, I guess is where I would go.
Justin, Troy?
I think Wade gave a good answer.
Okay.
Absolutely.
Will there be changes to unit design to help combat future pandemics of airborne viruses that affect buildings?
I think this one tags on to what we've already discussed. Are there going to be changes in the industry? Yes, there are. Is it going to be equipment based? Is it going to be control strategy based? I think check the box, all of the above. There's a lot of innovation going on out there, but I think, at least I hope we don't all sweep this under the rug and forget about it, because I don't think this is going to be the last pandemic we've got to deal with.
I think it becomes an owner's thing, right? So like if you want to go to MERV 13As, you're going to need 4 inches or more or 8 inches of filter depth. And so maybe that becomes your standard. Or, hey, we're going to go with UVC because we believe this technology works. Well, that's an intensity and a distance. And so you may now start after the coil requiring 24 or 30-inch access, which would be great for cleaning and other things. But so I think the answer is it comes down to the designer or the engineer of what they feel they ought to do, as well as owners having their design standards updated. I don't know, Troy, do you have another concept?
I agree, because it's definitely going to cost a little more money in the design, and construction phase. So if the owner's committed to that, then, they may go that route.
I mean, that's a great point, Troy, about the cost, right? If I told you I was building a lab building and and I gave you a price, you wouldn't bat an eye at it. But if I told you it was an office building, you'd look at me like I was nuts, right? And that's taking a building built for comfort to operate for safety that we're now giving it a little bit more safety levels. And so it's going to change if they want that added or future proofing of their systems.
Great. I'm going to combine two questions here in case they've already been partially answered with respect to technology. Somebody's asking about needlepoint ionization, which I'm not clear if that's the same or different technology from the bipolar ionization you've already been talking about. And a separate question came in about how effective are UV lights?
So the needlepoint is a specific manufacturer's patent application of bipolar ionization. And whether it's still considered bipolar ionization is argued amongst individuals, but not to say that but most in the industry lump those together. Bipolar ionization, needlepoint get put together. Some will tell you that's wrong, but it's, then the other piece was the UV lights. I always think UV lights, as I said before, is distance and intensity, right? And so I always kind of do it as if I take a candle and I wave my finger across it, I don't get burnt. But if I put my finger on it and just leave it there, I'm eventually going to get burnt, right? Now, if I put a blowtorch in front of you, I'm not going to even put my finger across it, right? And so with UVC, in terms of it is shown to be effective against the virus, but it's a matter of intensity and duration. And that duration time is your air velocity and that distance it takes, to get you that duration, if you will. And so it has been shown, it was, shown to be effective against TB, the original SARS and others. So, but that is what you have to try and figure out for your system. Is it effective in my system that I have in the account? Do I have enough downstream off my coil, for a realistic amount of intensity? And so that really is more of the question, is if you're looking to use it, can I use it?
And to add to that, Wade, I think, the way that we see UV being used right now is we have a continuous source of light on a coil to handle, the biological. Well, that's your duration. So it's always shining on it. But as the air passes that UV, it doesn't have much of a chance to have an effect, on the virus. So it's a whole different application when we're trying to, kill a virus with UV. A lot more intensity, a lot more duration. So they may have to be the lights oriented differently so that the particles travel along that distance. And I think that was your point about making more space in the unit casing, right? To allow that time.
Correct. Sometimes you see them parallel to, or instead of perpendicular to the airflow. So
yeah, so it'd be a whole different thing than what we're, I think, accustomed to seeing out there.
So guys, one more. This is a fairly long setup on this question. If you can see it, is this worth? Is this something you've already hit through other questions? I've had no problem reading it.
The last one that gets into hot and humid and
Right.
the amount of outdoor air and systems not being potentially existing systems not being able to handle it. The one thing is, that are shut by operators is that ASHRAE requirements for continuous fan operation. And that's one of the things that, so this is probably a longer answer than you're going to want, Ray, but in essence, there was an early article that came out written by an individual that is actually very talented with an HVAC. It was written in March, intended for and it fell under if your systems can operate, run them 24/7 to help continue to move air through your building. But the inferred piece was not if it's really impacting your energy at a great deal, right? So if I'm 50 degrees outside and I can do potentially do full economizer, and now at that point you're using fan energy. So, but that was an article written by an individual. It happened to be in an ASHRAE publication, but that was not ASHRAE's stance. Then the original guidance came out and there was some nuances that stated, hey, you might want to run your building 24/7 or run your toilet exhaust 24/7. But as everything else, we've been modifying and adjusting to make sure that we're doing and recommending the right thing, right? There's been studies that compare how much outdoor air versus filtration and what's the cost to doing that. And not shockingly, better filtration wins over more outdoor air. And so that current ASHRAE guidance does not state to operate your buildings 24/7 unless there is people in your building, and they should be operated at a 24/7. And so I think that is the key part of that question, which is trying to get everyone to understand, is it is not run your buildings 24/7. It is run your buildings when people are in the building, do the flush between occupancies, and have your systems, once again, code minimum outside air, equivalent to MERV 13 filtration, and that's kind of the where it's headed. So I think that answers the question. It at least answers the part that I was most concerned about when I read it.
Guys, Justin, Troy, you good with that?
Good to go.
That sounds good. I think we've covered a lot of that. So.
Yeah.
I've got a handful of rapid fire questions, and maybe we can, at least I think they're rapid fire questions, and we can maybe use these to close out. Justin, for you, should I disable economizers since you said to disable DCV?
So that would be, I'm not sure if I came across as saying to disable demand control ventilation. I'm not sure that that's accurate. The disabling economizers, that would be, you don't want to do that. I mean, you can use your economizer if the conditions are correct to increase your ventilation. Especially this time of the year and going in, depending on where you are, for this would be a good strategy right now to try to achieve some of what's being advocated. So I think maybe that was misunderstood. But you certainly need to monitor what's going on in your space. Demand control ventilation, by and large, in the industry now, and not in all instances, is looking at CO2 and maybe other things like that, which should, or at least that's the case, is that should give you occupancy levels to drive your ventilation. But I think here you're trying to, based upon your occupancy and looking at it from an engineering standpoint, increase your ventilation as much as possible. You can still operate it across a range utilizing your demand control ventilation. But if you're going to follow the recommendations of ASHRAE, you're going to want to just try to increase your ventilation as much as possible. Wade, did I say something wrong there?
No, you're good. I'm with you. Disabling of demand controlled ventilation is making sure it's designed to reduce it. So you're just trying to say, no, bring in what your air handling unit can handle. But if you've got economizers, let it ride. So
I've got one more for each of you here. For Troy, and again, apologies if you guys have covered a lot of ground. So if you've already touched on some of these, just let me know. But for Troy, with higher MERV, will it always require me to change filters more often than what I have now?
So a couple of things with a higher MERV, higher pressure drop. One thing from an O&M standpoint that I heard mentioned, as far as alarms were concerned, is those set points would need to be adjusted first, right? So that we know the new alarm set point for the dirty filter on the MERV, and you would likely have more frequent changes of the MERV filter. But I think one of the important keys there is to change that alarm set point so that you know, based on the manufacturer's rating, what is the dirty filter set point. And then there's a variety of factors that are going to affect how quickly it loads up, conditions in the building and things like that. But I think the takeaway is just make sure that you know what that setting is, and then respond to it on an O&M, from an O&M standpoint, to get those changed out.
Great.
Yeah, I'm going to add to what Troy's saying, because we're working with some clients on this right now. A lot of times you don't know what that period is. And so if the test and balance folks are engaged, and hopefully they are, to help with that effort to increase the filtration like we're advocating in this particular session, one thing we're suggesting is let us come back in a month, 2 months, 3 months down the road, wherever you guys anticipate on this first go round. Let's give you some good data. Let's try and see what you can do here, because we know you're going to need to change it more frequently, and we know we're affecting the performance of the equipment. Let's not just change it and walk away. Let's give you some good data, and that way you can change your operations if you need to.
Thanks, guys. Wade, last question directed initially to you. During the analysis phase, should a facility have an overall plan for preferred mitigation strategies?
Absolutely. If you look at it, in HVAC and non-HVAC, right? We talked about wearing masks and directional flow and their reduction on the bioburden that the HVAC system may have to take into account. But, these are buildings or facilities or campuses that you still have to maintain. And so if you start throwing, 8, 9 different technologies into different buildings, now you're just adding to that maintenance amount of effort that is required. And we already talked about how much deferred maintenance is really out there. So we've actually done it with a handful of clients where the first sit down is, okay, what is your preferred methodology of how you would like to progress? And then you go out and look at the systems that are all unique and different and say, okay, we can apply it, we can't apply it. And you kind of work down that list to try and to keep consistency for an owner between their buildings.
Great, thanks, Wade. So I'm actually gonna close this out at first with a comment that came in, not so much a question, but a comment that came in from one of the attendees that's really amplifying something you guys talked about earlier, saying that I believe what you're saying about teamwork, addressing it as a team is essential. Hopefully not throwing everything onto the design professional and engineer. The design professional will be relying on data provided by TAB, commissioning, and others to contemplate possible solutions. And I think that's really important listening to you guys today and the interplay, of your different disciplines and your point that this requires a lot of different kinds of expertise. You got to stay in your own lanes in some cases, but you really need to pull yourselves together to come up with the best possible solutions and avoid any unintended problems that come out of all this. So I just thought that was a kind of a nice way to wrap that up. I want to thank all of you for your time. Obviously, we went way over, but we've got the vast majority of our attendees still here, and thank all of you for hanging in with us this long. We really appreciate you being here. That concludes the session today. You'll all be getting your continuing education certificates in about a week, maybe a little bit more. So do look out for that. And we also hope to see you starting with next week's presentations beginning on Wednesday. Make sure you're signed up for that and have your links. So thanks everyone again for being here. All our panelists, thank you. Give yourselves a round of applause. That was fantastic. And thanks from AABC, and thanks again to our sponsor, Engineered Air Balance. Take care, everybody.
Yes.
Thank you.
The Associated Air Balance Council, the world's oldest and most respected association of certified, independent test, adjust, and balance agencies. AABC offers its members and the industry technical education and training, an ANSI-approved TAB standard, and a variety of resources with the goal of ensuring that systems are tested properly and operate as designed and intended. Let's take a look at why independent test and balance is important and why AABC certified agencies are the service providers of choice for every building owner and design professional.
The testing, adjusting, and balancing process is a benefit in many different ways to the owner. That not having the process done may save some dollars on the front end, but the process in itself is all to make sure that the owner receives what he paid for.
For my customers who are either building owners or operators, independence matters because they're getting an unbiased view at their mechanical install, at the design, and actual end performance of the equipment that they're having tested and balanced.
Well, they just get a better product. They get somebody who's looking at all the pieces and how they all tend to work together.
For me, independence is more about trust than it is anything else. Knowing that when they come into the room with a problem and they've got an independent entity as a tab agent and they know it's independent because they're certified by AABC is the most important part to the process.
They're high quality, high caliber people who are extremely driven to make high energy efficiency buildings and make an impact on what really is the demand of the future, which is the energy market, and how do we make sustainable buildings. And I haven't seen a group of people at any of the other organizations that have that knowledge base that AABC brings to the table.